in Electric Dreams, just like most other JavaScript projects that we will work on, one of the things that we need to do is we need to find a way to gain access to the elements in our markup. If those elements have an ID attached to them, Query Selector is a great choice for doing it, but it's not the only choice. So we can use it as an option, but it's not the only one that we want to use as we go through. As we tried to gain control of our markup, Query Selector being an easy way to do it, we do have other options at our disposal. We also are able to get elements by ID. But when we get an element by ID, we will notice that much like Query Selector, we're referencing an ID. Query Selector, we referenced computer. And now get element by ID. Notice element is singular, I is capitalized, D is not. But a distinction is when using Query Selector, we have the hashtag or # in front of it, the same way we do in a CSS rule. When I use the document get element by ID, I do not use the hashtag in front of that ID. So that is a difference between the two. So if you go back and forth between them while you are writing your code and wonder why suddenly your code broke, it may be you forgot the hashtag. It's not a big deal and it's super easy to fix. Those two are pretty similar. But when we want to access something by its tag, so if something doesn't have an ID or class or other hook for us to try and grab it, we can use get elements by tag name. Notice elements is plural in this case. When we are working in a good code editor like Atom, Brackets, or Sublime, it will help autocomplete when we type these in so that it will give us the correct capitalization and plural or singular version of get element by ID, get elements by tag name. So our code editor can help with the memory of that. But if you botch it, you just go look at a previous project, look at the code, or you quick do a Google search to go, what's the syntax for because I'm having a brain fart? No big deal. If you don't type it in for a month, you'll probably forget the exact nature of the syntax and have to go look it up. Totally fine. But get elements by tag name doesn't return the element. It returns an array. So if there were multiple buttons on my page, when I say var button is equal to document get elements by tag name button, it would create an array with all of those buttons in it. And then I have to say which one I want by using the array notation of square brackets and a number referencing its position in that array. So if I had 3 buttons on my page and I wanted the second button, I would put a number 1 because their positions would be 0, 1, and 2. Now, the next thing that we are going to look at is add event listener. We've talked about it before. We'll talk about it again. We can see that if I click on the button, it calls the click handler function, which then in turn calls my play game function. When I press a key down, and if that key happens to have the key code of 13, which is the enter or return key, it too calls play game. And then I have the play game function defined separately. This allows me to prevent repetition of code. Because play game is really just one line of code at the moment, it would be just as easy to put that line of code inside each one of these functions corresponding to its relative event. But once it grows into 50, 100, 200 lines of code, I don't want to repeat that in my click handler and repeat it again in my key down handler functions. That would be bad form. A good practice when programming is to not repeat yourself. So if you can structure your code to write a function and then call that function from multiple places, that allows you to avoid repeating code, which is wasteful and potential for errors. Because if you repeat the code, but then you make a fix in one version of it, but not in the second, you won't realize that you have a problem until that other event occurs, and then you'll be confused because you're sure you fixed it already. Another reason that we can't just call the same function both times is when I'm clicking, I'm just going to call play game because my button itself is listening for that click event to happen. So I don't have to say, okay, the user clicked somewhere on my screen, and then I have to look more detailed and go, okay, where did they click? Does that correspond to the coordinates of my button? If I had window at event listener click, then I could be figuring out the math to find out, did the user click where I have that button located on screen? But because the button is able to listen for the event on its own, we don't have to do that, so the click handler can just call play game. But this function, the event occurring for this function is a click, which is different than the event that's occurring in the key down listener, because that's responding to pressing a key down on the keyboard. And because we want to then be able to use that event, that now links this event function to the event listener, because we're now making reference to that event. So that's why we can't just use the same function both times. So I can't just put handler here and call the same one. That will fail. With my document, I can now hit the enter key and we can see play game was called, and it changed the inner HTML of computer. So if we look, where is computer on here? So I have a computer paragraph, and it changed it to yo, which is what I asked it to do. So it's not responding. I could type in whatever I wanted. It doesn't matter. It's not analyzing it. It's not even looking for anything. It's just simply, if I hit return or if I click on the button, it will change the computer's response to yo. To think through the logic of how this is going to work, we need to determine our order of business. The first step will be develop a suitable random response for the computer to provide. Then we'll update the text in that field, and then we'll wipe out the player's input so that it is clean and waiting for the player to type in something else. So by setting this up, in the beginning, we're not going to have a smart computer. It's just going to come up with answers, and it will respond. We type, it gives us answers. Then we're going to start refining that process as we identify that there are shortcomings. And as this project evolves, what I want to see happen is that you then try to address those shortcomings and add additional layers of logic and complexity to make a smarter and smarter, or sassier and sassier chatbot. So that's our ultimate goal or aim that we are working towards here. We have a few more variables that we will want to use to pull this off. So previously, when we were working, We had variables. We hadn't done too much with them. We have a response number. We have a new response, human, computer, and generic. Those were in the document. We weren't doing anything with it. Now this time we are going to start using these values. The response number, we store what we are responding back to the player. The new response will be where we want to make sure we're not duplicating and giving the same answer twice in a row, because then our computer seems stupid. I mean, it's going to be a dumb machine anyway, but we don't want to emphasize that fact. And then we have our messages. Now, the first use of the array that we are looking at is we will have generic responses that we are providing to the computer. The computer will be able to respond back with a number of responses. You can edit these. You can add to this list. You could make the list 20, 30, 40, 50, 100 responses. And in doing so, you create the illusion that it's not just choosing from a set list of possibilities. When we only have 3 answers, it becomes very apparent that our computer has a very small vocabulary. For development and testing purposes, I would encourage you to leave it at a low number like 3 until you have your program logic worked out. Because as you work with the program logic, and if you put in a lot more choices, it takes longer to find out, does your program even work? So if you put 20 answers in there, it's going to be a little bit trickier to find out, do all 20 work? Now, as I look through playing the game, what the computer does is it sets response number equal to a random number where we are multiplying a random number generated by JavaScript, which is going to give us a value 0 up to but not including the number 1. So 0.99999, about 16 decimal places out or so. And it multiplies that by however many responses are in the response array. And then we take that number and we round it down. So in this case, generic response's length is 3. And if I take any number between 0 and 0.9999999 and multiply it by 3, the possibilities are going to be 0 and 2.99999. And we round down, effectively cutting off anything after the decimal point. So that means my possible values that can be generated by this will be 0, 1, and 2. The random number has been determined. We will then set the computer message equal to that element in our response array. So going back up to find the response array, there's our generic responses. So it will now, based on the random, in this case 0, 1, or 2, it will plug that number in, and then that will set the computer message equal to that. And then we set the inner HTML property of our element equal to that string, which in this case will be either good for you, you are a loser, or I like you. If I run the program, I will see every time I click, it's going through that. But periodically, I'll click twice or more, even 3 times, before it now updates to a new answer. So a problem that we're running into is that it's possible to keep drawing the same random number in a row. And when I do that, and our computer repeats its response, it breaks the illusion that the computer is having a conversation with us. Thus, we need to move into version 2. To prevent the computer from generating the same result multiple times in a row, we can use a while statement. So what it will do is it is going to attempt to create a new response, and then it compares that new response to the previous response, And then while that new response is the same, meaning it's the same number, so math floor math random times my generic responses dot length generated the same number as our previous response, then it's going to try again. So a while loop forces the computer to keep executing that loop until the situation occurs that it's no longer true. So it will keep testing new response against response number until new response comes up with a different result. In this case, because it's a pretty low number of options, there's really no possibility of it getting stuck in a permanent loop because there is an escape clause, meaning we draw a new random number. It's safe to use our while loop. So we can use the while loop and just tell it to keep running until we get a new response. And once we do, we update response number, update the computer message, update the HTML. So this part is now the same. It's the same as what we used before. The new part is we have a new response, and we're comparing that to the old response. And once we do have a new number, then we update the old one to the new one, use it. And that allows our computer then to keep giving new answers every time we type something in or press the enter button. The same result every other. You're a loser, I like you, you're a loser. Okay? Well, either it's a really obnoxious computer, which that may be part of it. You may put the same answer in more than once so it fits with it's being really obnoxious to you. That could be part of the behavior of your machine. But it's not ideal as well. So let's get rid of that and let's try version 3. Now, version 3 is going to behave a little bit different in that version 3 is going to do something we haven't done to our arrays before. And that is we are going to use the splice method on the array. And what the splice method does is it allows us to say what element in our array we want to remove. So in this case, our array is currently 0, 1, and 2 positions. So response number will have a value of 0, 1, and 2. And we say, OK, remove something. And then we specify how many items from that point and after do we want to remove. So if I said response 0 and put a 3, my splice statement would actually nuke everything in my array. And that'd be bad. In this case, if I said 0, 1, that would remove the first element in my array. If I said 2, 1, it would remove the last element in my array. If I said 1, 1, it would remove the middle element. So splice allows us to remove something from our array. There are other methods that arrays have for adding and removing elements, but this allows us to target a specific element, provided we know what its position is in that array. So that's the one caveat here is we have to know where is that element in the array. And because response number tells us where it is, we can then use it. So if we say new response is going to be there, then we set our response number equal to the new response, we update the computer's HTML, and then remove that element from our array. So now if I hit enter, we get you are a loser. Now our other two options will be I like you. Now we're down to our third option, which is good for you. If I try again, there won't be any elements left in my array. And the computer decided it was done talking to me and it left. Looking at the document in our browser, if I hit the button, we can see that our array now only has 2 elements left in it after the first time. So our next 2 options will either be you are a loser or I like you. Now we can see it said you are a loser. It spliced itself out. All that remains in the array is I like you. If I hit enter again, we'll see that now the array is indeed empty. And after 2 seconds, the page is going to direct itself to a new location. After I hit the button one more time, then it does its final response and then directs to a new location. So our page, as we are looking at it, after the response array is empty, so as long as there are responses, it goes through this logic. Once we've run out of responses in the array, meaning the length of the array is not greater than 0, then it will go through this next chunk of code where it has its sassy response. It gets rid of the ability for me to enter any more input. It gets rid of the button by changing their classes. It changes the classes to display none, so it makes them disappear from the screen. We didn't remove them from the markup. We certainly could have used the JavaScript to actually extract those elements and delete them from the markup, but it's just as easy to just change their class, since we've been working with that as a technique so far. And then we use the set timeout method, which calls the endgame function in 2 seconds, or 2,000 milliseconds. Endgame uses the assign method to assign or send our page to a new location. So using location assign leaves the back button working. If I instead change that to replace, so it's location replace, now when we look at our page, where previously when it ended, we still had a back button. This time, when I go to my new location, I can't go back. To notice that after each one of these methods, there is this little value down here at the bottom. Every time the user enters an input, when the computer responds as part of our play game function here, it's also going to set the contents of the player's input field to an empty string. That effectively clears that form field. So that's how we can clear out the form field. We did it on Mad Libs. We can do it again here as a way of doing it. So version 1, 2, 3, and 4 all in index2 document happen, and then the final line in play game, it wipes out whatever the player's input was, so it's ready for the player to provide more input to the computer. In version 4, still in index2, one of the things that we will do is we are going to analyze what the user has input. And what we are doing as part of this analysis is, the first thing to make our analysis easier is we need to take what was input and put it in lowercase. Because when we are doing comparison, if they typed in capital G-O-O-D, that, as far as JavaScript, is not the same as lowercase good, or all caps good, or all caps bad. Because a string, or a collection of letters, is a case-sensitive element. So capitalization counts. So when we are trying to compare what has the player input to what we are looking for, it needs to match capitalization, or our search is not going to return results. So the first thing we do is we take the input of the player and knock it down to lowercase. Once that input is lowercase, then we are going to ask the computer, ask JavaScript to analyze that input for a specific collection of letters. We would call a collection of letters a word, but really all we're doing is saying, does this sequence of letters exist in the letters that were input into the field? That is what we are asking. Because JavaScript doesn't understand the concept between a group of letters or a word. It doesn't know. So we're just saying, does this group of letters that we put in quotation marks exist? And if it does not exist, when we use the indexOf method, JavaScript returns a value of -1. Otherwise, it returns a value of at what character number in that collection of letters does that term start. So if I typed in good, it would return a value of 0 because the first letter is at position 0. If I typed in I space am space good, it would then return a value of 5 for good. So if I type I am good, it would say, yeah, that exists. It starts at 5. But if I said I'm okay, good doesn't exist in that phrase. So it would return a value of -1. So when I say human message index of good, meaning does the word good appear, if it appears anywhere, that means it's not -1. So then the exclamation mark double equal sign is the same as saying the word not equal to -1. Because I can't really ask, I can't say, well, is it at 5? Because I don't know, did they say I am good? I am pretty good. Well, now that's even further out. So we don't know what number it's going to start at. So what we care about is it not there? So that's why we're asking the question, is it not part of this? So we say, if good is not there, meaning it did not, so we're saying, if good is there, meaning we didn't get -1, then we type in a message that means the computer acknowledged I said the word good. If bad showed up, then it's going to respond with a message of, wow, you live a sad life. If I didn't say good or bad, or it didn't detect those, then it will come back with the reply, you know nothing. So I typed in good, it said that is good for you. I type in good again, or misspell it. We can see now it says you know nothing because I didn't type in good. If I type in bad, you live a sad life. If I type in bad good, that is good for you. So what is happening here is it's analyzing this in a specific order. When I type in bad good, we get the good response because it looks for good first. That is a shortcoming you will have to learn to live with. It also means you have to be more creative of how you're going to implement this to make it an engaging project. Now what's going to happen is as we move through this in our completed project is when we analyze a question, if we find answers, then we are going to start out with a new question, and that question is going to then set us up down a path for the next round of analysis. So if the player answers good, then we reply back, I'm happy for you, what's your favorite color? Totally random connection of color to good, except that, well, if they say good, maybe we can analyze the color to find out more about their personality or mood. If they say bad, well, say, dogs, are good companions. They make people feel good when they have their dog around. So if they say bad, we're moving into that category. So we're trying to apply a little psychology here. So we're thinking about how the question might respond. So if we take the answer, we'll just continue with color first. So good, we ask a new question, color. Well, if our track is going to be color, then we are going to use color analysis as our next round of question solving. So now if I move into and find color analysis, I'll see, okay, well, in this case, I look for red and blue. Just two basic colors. If you ask what's your favorite color, if you want it to work, you probably need to put a bunch of colors in there, not just two. If you put a dozen colors in there, you're going to cover a lot of situations. And then you always put a catch-all, which the catch-all can just be, in this case, the generic responses, which send you into the death spiral of 3 answers and then you're out. But the generic responses could also be new questions that lead you down a new question track. So if they don't answer one of the ones you want, then you could move into a new question track that's totally random and continue this process. And it's like Alice going down the rabbit hole. How deep do you want to go? So we analyze the color. It's red. Okay, now we give a response with a little bit of personality and ask a question. Now we can see that's going to lead us to the date track. Now if we go find the date track, date track has not been completed yet. When the question track is set to date, well, it goes, is there start? Nope. Color? Nope. Dog, cat, dog owner? Nope. All right, then it moves into our generic response. So the way that a switch statement goes is it tries to find an answer. If it can't, it uses the default case at the very end. And the default case in this option will lead us into our generic responses. Once we do that, it is now going to be those early responses that we saw before. Good for you, loser, I like you. And after those are used up, then it sends us into the end game spiral, which then directs us to the Electric Dreams webpage.